Okay, so we have already seen the dynamic loading and then dynamic linking, and then we have seen also seen the overlays. Now we are going to discuss some other approaches of the memory management unit, that how the memory management unit actually allocates the memory to different type of processes, right? So we will see that what are the categories of memory allocation unit, right? Categories of the approaches of the memory allocation unit. So we have two basic approaches. The first one is contiguous memory allocation, and then the second one is non-contiguous memory allocation. In the contiguous memory allocation, we have further two uh, type of approaches. The first one is single partition, right? And the second one is multiple partition. And inside this multiple partitions, we have again um, fixed size partition, and we have also variable size partition, right? While on the non-contiguous memory allocation, we have uh, the paging and we have segmentation. Okay, segmentation. Right. So we'll be seeing these categories, these schemes, these broad two categories of the memory allocation: the contiguous type of memory allocation and the non-contiguous type of memory allocation. Okay, and then in the contiguous, we will be seeing a single partition and then multiple partition, and inside multiple partition, we'll see the fixed size partition. Okay, so the contiguous memory allocation is actually a continuous type of partition, where a continuous type of memory allocation where every process here, or suppose this is process and it might have 1 and 2 and 3 k of memory, which is going to shift it to the main memory, a process which is going to shift into the main memory. So this allocation should be continuous, which means that uh, this uh, the places in the main memory should be contiguous in nature. Okay, consecutive memory allocations should be there. This is why, because it speeds up the speed, okay, and efficient utilization of CPU utilization, right? However, this might lead some drawbacks also. We'll be discussing those here, and and we have also non-contiguous memory allocation. I have already told you, non-contiguous is when these 3K of memory is stored over the different locations of the main memory. Okay, here, for suppose this type of memory storage memory allocation is non-contiguous. Okay, this is non-contiguous and this is contiguous, right? So uh, the contiguous type of memory supported by both operating system and the user program, it must be supported, and limited resources must allocate efficiently. And also there are two main partitions. Now we come to the single partition and the multiple partitions. I will just insert a blank page here. Um, white screen, right? Okay, so we have further two divisions of contiguous memory allocation. The first one is single partition. Single partition. Why this is single partition? Because we have always two partitions of the memory. Here, if we see that we have one is operating system, and then we have the user programs in the next partition. So because for the user processes we have only one partition, that's why we call it as a single partition, right? And first suppose this memory is 0 to 3000, right? And from 3000 to 8000 is user programs, which means that 5000 K is the capacity of this RAM. Now for suppose if one process has come here, right here, and it is maybe a only 1000 K long, so what will happen that the the portion of the memory is allocated to this while the remaining portion is wasted here. Okay, so that's why here we have the memory wastage, and we can only have one process in the main memory at a time, one process in the main memory at the time of execution, at the time of execution. Okay. And while the remaining memory is wastage. The remaining memory, for suppose here we have 5000 K, and 1000 is utilized, but 4000 is wasted, right? So 4000 is wasted in here. So that's why to efficiently utilize the memory, because this is a costly resource, costly in terms that as long as you go near to your CPU, the memory units becomes costly, because you can have 2 terabyte uh, hard drive, but you cannot have 2 terabyte RAM, because as long it is the minimum memory, and they are very close to your CPU. That's why to deal them efficiently, we have to keep them with minimum size. As long as you go further near to your CPU, for example, cache and register, then you will be dealing with very small amount of memory. So the main memory is also costly resource, and we have to utilize this efficiently. And there is a huge wastage uh, while using the single partition. Now remember that in single partition or multiple partition, the portion, the pages or the parts of a program are required to store in consecutive way, right? Because this is the subpart of this is one of the schemes under the contiguous partition, contiguous memory allocation. Okay. Now second one we have multiple partition approach, right? In multiple partition approach, what happens that we have for the two approaches, I must tell you that we have fixed size partition, right? And we have another is variable size partition. Okay. Now in the fixed size partition, what happens that we have this main memory, and we have operating system already loaded in this, for suppose, and now we will divide the remaining memory into some partitions. Okay, this partition may vary in the size. For example, uh, the operating system is loaded up to 3000, then maybe up to 500 is allocated to this space, then this would become 3500, and then this might be 4500. Maybe this is for 1000, right? 1000k, this is 5000k, 500k, and then we have maybe 700k, right? 7000, then this is might be 2500, right? And then we have also 200 more, 72, right? 7200, and so this is only 200k, and so we can have variable length of the partition, but the partition size is fixed here, right? For example, we can have also 500k partition of all these partitions in the main memory, right? The size can be varied, but yes, the size can be different, but it should be fixed, right? Once this is fixed, you have to fit all the processes within this partition limit. Now, for suppose in the case of fixed partition, if I have, I'm just trying cleanly here. All right, if I have operating system already loaded here, and I have two partitions, maybe three partitions. Okay, now this one is only 5 kg, 5k, this one is 10k, and this one is 8k, and this one is 2k, right? So we have different size of partition. Now suppose if I receive one process which has 3k data, right? 1 to 2 and 3, which has 3k data to store. Now what will happen, that we'll see that which partition is appropriate to fit this, right? Here this is 2, and this is 10, and this is 8. Well, this is fine. So you can see that we can fit this new process into this partition. So 3 out of 5k are utilized for this process, okay, for bringing this process into the main memory. Now what happens, that we have 2k is wasted here. Now for suppose another process has arrived, and it is maybe 9k, right? It is maybe 9k. Then this will be allocated here, and after from 9k, from 10k we have utilized 9k, but still 1k is remaining here. Now we see 3k data, another process of 3k, right? And we have shifted that here, this, and we might have utilized some portion, but still 5k are wasted here. And for same reason we have 1k process which is right here, then we have utilized 50% of this, but 50% is still wasted. Now we see that this wastage is still in the partition, because for suppose now this 2, 1 and 5 and 1, right? So we have almost 9k of space is still available with the main memory, but we cannot use it because uh, this space is not contiguous in nature, and we are dealing with the contiguous type of uh, memory allocation. So this space is not contiguous in memory, even if one process has arrived, and it is maybe 7k, right? And we have 7k, like here we have 5k and we have here 2k, but we cannot utilize this for this process because this memory is not contiguous in nature. Okay, to overcome this issue, we have variable type of partition, right? Variable size of partition. Now what happens with variable size of partition, that we have operating system, right? We have operating system, and then we don't have actually any partition here, right? For example, this is whole operating system. Now we don't have any partition here. If a process come here, for example, if a 2k process come here, it will be allocated here, right? It will be allocated here. Now next, if another process has come, for example here, this is the operating system. Now this one is already occupied, and we receive another process here, right? We receive maybe another process of 5k, okay, that is written over here, okay, and then we receive maybe 7k, another process that is also written over here. So this is actually the variable size of partition. Okay, so because the upcoming processes are adjusted in the whole. This thing is the empty space is called as a whole, where all the incoming new processes are adjusted, and these are adjusted again in contiguous fashion. Now the problem here with this approach is that, for example, if this is process 1, this is process 2, and this is process 3, and here we have this is 1, this is 2, and this process is 3, right? So what happens that if we are executing at some time and the process 1 has finished its execution, right? But the process 2 is there, process 3 is there, right? So process 1 has finished its execution, it was 2k, so we have 2k free here now, right? And maybe we have 3k remaining as a whole here, okay, remaining as a whole here. Now for suppose if we receive a new process, if a new process has popped up, okay, and it is 5k. Now we have 5k memory space available here, but we cannot utilize this. This is also a problem, similarly to the previous problem like we were seeing here. Okay, now such problem, when you have the space, when there is some space wasted inside the partition, that thing is called internal fragmentation. That thing is called internal fragmentation. Okay, and when you have collectively some space but you cannot utilize because these are not consecutive in nature, then this thing is called external fragmentation. Okay, external fragmentation. Now we'll see contiguous allocation. We have already seen that what is contiguous and non-contiguous, and we have seen single partition and multiple partition. Now we were facing some issues with the contiguous. We have also seen the variable type of partition. You can see here that the process 5 has arrived, the process 8 has arrived, process 2 has arrived. Now if process 8 is already finished, then process 9, if it's small, it can be adjusted here. But if process 5 has finished, now we have two partitions, two holes, which are free, but they cannot be utilized by a big process because they are not contiguous in nature. So this is what the problem, that holes can be scattered. The various holes are scattered throughout the memory. So this is what the problem with this variable type of partition. Okay, so these are some contiguous memory allocations. Now to overcome this issue up to some extent, we have some algorithms which we call first fit, best fit, and worst fit. These are actually approaches. Now first fit is that in the memory we see that if something, for suppose if I have a 5k data to write, and if in the main memory maybe I have 2k and 8k and 3k and 5k and 6k, right? Partitions available in here, maybe options available here, maybe holes or maybe partitions we have. So what happens that we will find and we'll see that whichever the first fit we find, this new data, this new process will be moved to this location. So though we have 5 here, but still this will be moved to this location on the 8th on the box of 8k. Okay, then next we have best fit. This is efficient first fit because there's no search time, very less search time, not no but less search time required, right? Now base fit is go through all the locations of the memory and find out the best fit option, which is here 5k box. We have a 5k memory location, so this process will be best fit for this memory location. Okay, so in this the leftover is very small. It means that the fragmentation is very low. We have a lowest fragmentation in this when we are adopting this approach, but the searching time is high. because we had to go through all the memory locations. Searching time high. Okay, timing is higher. Okay, now we have also first fit. First fit is we look throughout and we find, for suppose this is 11K, and the largest block to write this new process is this 11K. So this will be fit in, and this will be sent to the largest hole. Okay, and now in this again the search time is also high and fragmentation is also high, because we want to make sure that fragmentation, the fragments we have created, should be minimized. Okay, so base fit and first fit are the most preferred approaches while we are dealing with the dynamic allocation problems. Okay, now fragmentation, I have already told you that we have two types of fragmentations. The internal fragmentation, when you have some memory wastage inside a partition, and external fragmentation is when the internal fragmentation is cumulatively uh, combined, and it is called the external fragmentation. It means that all the internal fragmentation, if you combine these all and you have enough memory but you cannot facilitate a new process, then this thing is called the external fragmentation. Now total memory space exists to satisfy the request, but it is not contiguous in the nature. Okay, and internal fragmentation is allocate memory may be slightly larger than requested memory. The size different is the memory to internal partition, right? Because the internal partition and the new process has the size difference, and that's why some memory part is wasted, and that wastage is called the internal fragmentation. To overcome this, we have the compaction technique. Compaction technique is similar to the defragment. You might have used this option in the Windows PCs while under the system applications. Under the system applications, we have defragmentation. I'm not sure if new Windows operating systems has this option, but old maybe Windows 7 up to Windows 7, I'm sure that defragmentation option was there. And this is the option when the scattered. Now, for suppose if we have a memory here, and defragmentation is actually used for the hard drive, but when this approach is used in the main memory, then it is called compaction. Okay, so what happens in defragmentation? For suppose we have memory locations here, partitions, different partitions of memory here, and maybe we have something written over here, something is written over here, and something is written over here, and something written over here. So uh, these all written locations are actually brought together into a one big chunk of data, right? As was saying, memory is actually maybe written here in a way that the remaining portion would become a continuously whole, a continuous whole, a contiguous whole, right? To make the remaining memory as a contiguous memory, okay? So that the new processes, the upcoming processes can be facilitated for the execution, okay? But the problem with this approach, the compaction approach, is that for moving from one place to another place, moving data from one place to another place, we need the input output. The input output routines are involved in this, okay? And this is again not efficient and also not time consuming, okay? Not CPU efficient, okay, and also and time consuming, okay? So So this is the fragmentation, to overcome the issue of fragmentation in the multiple partition scheme. Now the second, we have paging here.